It is the Icarus of space travel. NASA has now published the latest images from the Parker Solar Probe, which show us the Sun's activity in unprecedented detail. The probe has captured images of the solar wind from close range, capturing an almost surreal spectacle that impressively demonstrates the wonders of the cosmos. But what is an overwhelming sight for us is even more so for researchers. After all, these close-up images are helping astronomers to understand our mighty host star more accurately than ever before. So, be sure to stay tuned until the end and see for yourself how our source of warmth and life is keeping the scientific world on its toes. There are many ways to spend Christmas Eve. But while the Christmas holidays are probably a time of cozy reflection for most of us, Parker Solar Probe had something different planned for December 24, 2024. Instead of enjoying festive meals and presents, the NASA space probe broke several records on that day. On the one hand, the Sunstorm managed to reach a breakneck speed of 692,000 km per hour, becoming the fastest man-made object ever. And on the other hand, it came within 6 million kilometers of the Sun. No other probe has ever come so close to our central star. And in the process, it also took a series of photographs that are absolutely unique and which have now finally been published by NASA. The groundbreaking images of the Sun's atmosphere provide researchers with unprecedented insights and at the same time allow them to draw new conclusions about the influence of the Sun on our entire home system. The significance of this is already clear from the assessment of Nikki Fox, who works as Deputy Director of NASA's Science Mission Directorate. She says, "Parker Solar Probe has once again taken us into the dynamic atmosphere of our nearest star. We are seeing where the threats of space weather to Earth begin with our own eyes, not just with models. The new data will help us significantly improve our predictions to ensure the safety of our astronauts and the protection of our technology on Earth and throughout the solar system." And when Parker Solar Probe got up close and personal with our host star in December 2024, it crossed the so-called corona during the days of its closest approach. There it collected a wealth of insightful data with its scientific instruments. And thanks to the Wide Field Imager for Parker Solar Probe, or WISPR for short, we can now marvel at the corona and the solar wind from close up. A fascinating insight into the Sun. But first, let's briefly clarify what exactly Parker Solar Probe captured. In general, the corona is the Sun's atmosphere. More specifically, however, it refers to the outermost layer of the atmosphere, which is an extremely hot and thin plasma shell surrounding the Sun and extending millions of kilometers into space. In fact, the corona is many times hotter than the surface of our mother star. While the thermometer on the photosphere climbs to only 5,500 degrees Celsius, temperatures in the corona rise to between 1 and 3 million degrees. However, the exact reasons for these dramatic differences are not yet fully understood. One theory explains the enormous heat of the corona with magnetic reconnect ion or, in other words, sudden restructuring of magnetic fields that release large amounts of energy. The second theory is based on so-called Alfvén waves. These are magnetic waves that move through the plasma and transfer energy to the corona. The solar wind is a constant stream of charged particles that flows out of the corona into space. And this has noticeable consequences. The solar wind causes magical dancing auroras to flare up in the Earth's sky, occasionally disrupts our satellites and power grids, and last but not least, plays a key role in the formation and expansion of the heliosphere. This gigantic bubble of solar plasma surrounds our entire home system and shields us from much of the dangerous cosmic radiation from interstellar space. However, it's in the nature of things that we can only fully understand the effects of the solar wind if we also understand its origin in the Sun. And this is exactly where the new WISPR images come into play. These show scientists what happens to the solar wind shortly after it leaves the corona. More precisely, the images depict the crucial boundary where the polarity of the Sun's magnetic field changes from north to south, the so-called heliospheric current sheet. But that's not all. At the same time, Parker Solar Probe also captured the collision of several coronal mass ejections, CMEs for short, in high resolution for the first time. In a nutshell, CMEs are solar eruptions that eject plasma and usually originate from sunspots. At the same time, such large eruptions of charged particles also play a major role in space weather. And Angelos Foris, scientist for the WISPR instrument at the Johns Hopkins Applied Physics Laboratory, comments as follows. In the images, we see how the CMEs basically pile up on top of each other. We use this to find out how the CMEs merge with each other, which can be important for space weather. When CMEs collide, their course can change, making it more difficult to predict where they will ultimately land. At the same time, however, their merging can also accelerate charged particles and disrupt magnetic fields. And that is a potential problem, especially for astronauts, our satellites, and our technology on Earth. And so, it is that the close-up images from the Parker Solar Probe are helping experts significantly to better prepare for such space effects on Earth and beyond. The mysteries of the solar wind. It is of course no coincidence that the Parker Solar Probe is called the Parker Solar Probe. If you like, the US astrophysicist Eugene N. Parker did the fundamental pioneering work for the current mission. After all, he was the one who first introduced the term solar wind in 1959. Parker, who passed away on March 15, 2022 at the age of 94, was also the first person to witness the launch of a space probe named after him. He was even there in person. And although his theories about the solar wind were initially anything but uncontroversial, they ultimately revolutionized our understanding of our home world. Before the launch of Parker Solar Probe in 2018, NASA and its international partners had already sent probes such as Mariner 2, Helios, Ulysses, Wind, and ACE into space to gather new information about the origins of the solar wind. And although the previous missions had already provided valuable insights, they had one major limitation. They were all conducted from a distance. Parker Solar Probe is now studying the Sun at close range. It has even approached our host star to within 6.1 million kilometers. Now over 6 million kilometers doesn't really sound like a stone's throw, but that changes once we put this figure into perspective. The average distance between the Sun and Earth is around 150 million kilometers. And if we assume that this distance is only 1 m, Parker Solar Probe would be just 4 centimeters away from our host star. The data collected by NASA's Icarus gives us a detailed impression of the solar situation on site and sometimes with surprising findings. While the solar wind on Earth usually presents itself as a steady breeze, it is subject to great turbulence near the Sun. Approaching our star at a distance of 23.7 million kilometers, it registered zigzag-shaped magnetic fields which experts refer to as switchbacks. Based on the data, scientists realized that these switchbacks, which occur in dense, irregular clusters, are apparently much more common than previously thought. When Parker Solar Probe first entered the corona in 2021 at a distance of just under 13 million kilometers, it again found that its boundary was uneven and much more complex than expected. As it flew even closer, it finally helped researchers locate the origin of the switchbacks at spots on the Sun's surface where magnetic funnels form. In 2024, experts announced that the fast solar wind, one of the two main types of solar wind, is partly driven by these switchbacks, solving a mystery that had puzzled experts for 50 years. And while the fast solar wind whips through space at speeds of between 500 and 800 km per second, its slower counterpart takes a more leisurely approach. At 300 to 400 km per second, the slow solar wind is only about half as fast. The big question now, however, is how the solar wind is created and how it manages to escape the immense gravitational pull of the Sun. This is particularly true for the slow solar wind, as its interaction with the fast solar wind can generate solar storms on Earth that are sometimes comparable to the effects of CMEs. Parker Solar Probe will continue to help shed more light on the darkness of the Sun. The probe has already confirmed that, as suspected, there are two types of slow solar wind, which differ in the orientation or variability of their magnetic fields. And scientists are already eagerly awaiting the data that the probe will collect in September, when it will once again fly close to the Sun and reveal what surprises our mother star has in store for us. And the subscribe button is already waiting for you below our video. Just click on the thumbs up and then subscribe to stay up to date from now on. See you